Although the Celsius and Fahrenheit scales are widely used, the Kelvin temperature scale has greater scientific significance. It was introduced by the Scottish physicist William Thomson, known as Lord Kelvin, and in his honor each degree on the scale is called a Kelvin, or K. By international agreement, the symbol K is not written with a degree sign, nor is the word degrees used when quoting temperatures. For example, a temperature of 300 K is read as 300 kelvins, not 300 degrees Kelvin. The Kelvin is the SI base unit for temperature. We start by comparing the Kelvin and Celsius scales. The ice point, 0 degrees Celsius, occurs at 273.15 Kelvin on the Kelvin scale. The steam point, 100 degrees Celsius, occurs at 373.15 Kelvin on the Kelvin scale. Therefore, the size of 1 Kelvin is identical to the size of 1 Celsius degree because there are 100 divisions between the ice and steam points on both scales. As we will discuss shortly, experiments have shown that there exists a lowest possible temperature, below which no substance can be cooled. This lowest temperature is defined to be the 0 point on the Kelvin scale and is referred to as absolute zero. Absolute zero corresponds to negative 273.15 degrees Celsius. Thus, the Kelvin temperature, T, and the Celsius temperature, Tc, are related by T equals Tc plus 273.15. But from where does this idea of absolute zero temperature originate? Suppose that the absolute pressure of a dilute gas is measured at different temperatures. As the pressure decreases, the temperature decreases, and there is a linear relationship between them. Therefore, if the results are plotted on a pressure versus temperature graph, a straight line is obtained. The temperature will eventually get so low that all gases will liquefy, preventing us from measuring any further. However, we can extend, or extrapolate, the line from the other data points to lower and lower temperatures. The line eventually crosses the temperature axis at negative 273.15 degrees Celsius, which corresponds to the gas being held at zero pressure. Hydrogen or helium are usually used in such experiments since they liquefy at very low temperatures. However, when other gases are used, a straight line is always found that extrapolates to negative 273.15 degrees Celsius on the temperature axis. This suggests that the value of negative 273.15 degrees Celsius has fundamental significance. The significance of this number is that it is the absolute zero point for temperature measurement. The phrase absolute zero means that temperatures lower than negative 273.15 degrees Celsius cannot be reached by continually cooling a gas or any other substance. If lower temperatures could be reached, then further extrapolation of the straight line below zero on the temperature axis would suggest that negative absolute gas pressures could exist. Such a situation would be impossible because a negative absolute gas pressure has no meaning. Thus, the Kelvin scale is chosen so that its zero temperature point is the lowest temperature attainable and is called absolute zero. In summary, the Kelvin temperature T and the Celsius temperature Tc are related by T equals Tc plus 273.15. The temperature T equals 0 Kelvin is absolute zero, and temperatures below absolute zero are unattainable.